Hello, students. Welcome. Hope you all have had a wonderful weekend. We are now here on a Tuesday starting off for this week, back to our Earth, Space, Science e-learning, and we have just recently found out that we will now be in e-learning for the rest of the school year. In meetings with our school administration earlier, I've been told, I think we have now, as of right now, if I'm not mistaken, 6 more weeks of school till the very end of May. I think our last day, if I'm not mistaken, is May 29th, May 29th. So I will have to double check that. And I've also been told that we may have the possibility of the very last week, but what would otherwise be a finals week, a semester exam week. We have that last week to be just a makeup week for you guys to, so again, I'm not going to make any guarantees, but like I've said, let's just take it 1 week at a time, make sure we're ahead, because if we get work turned in late, that's only going to hurt you and your grades. So, but I figured since we're starting off another week here, let's go ahead right off the bat and show our new assignments, our new assessments. And as we can see here, I have scanned the workbook pages for you guys to access on Edsby. That is on its own post. The assignment post, so here is just the workbook pages, okay? Below that is just the assignment post. That just includes the directions and where you will submit your finished answer sheets with those workbook pages. Again, it says here they need to be on separate sheets of paper. You're not going to rewrite the entire workbook pages because I know a lot of us can't print these out at home. But what you will do is you will just simply write your answers with your numbers, with those numbers and page numbers on an answer sheet. Only thing I'd like you to probably rewrite is maybe the matching sections or the diagrams, right? So that way it'd just be easier for me to look at and grade from that point of view, but no need to rewrite all the questions outside of that. And then above the actual workbook pages, I have posted the textbook pages that have the answers that you can kind of click and read through to find answers for all of the workbook pages that were included. Those are 4 pages, 323 through 326, if I'm not mistaken. And you can find, I think, the majority, if not all, the answers on these textbook pages. They do not have page numbers because my textbook, the teacher's textbook, is different page numbers. So if you just kind of glance through the paragraphs and the topics, you'll easily find, I think, where you can find the right answers for specific questions. So I just wanted to specify that because we're at the beginning of a new week. Let's go back. We are now starting our second to last unit of the school year. Okay, and it's going to be Unit 8, Universe and Galaxies. Again, we start off smaller, all the way from the middle of the Earth, all the way to the most distant and vast, which is the deep space, right? And if we go here, go ahead and update a new table of contents. That is going to be a new page number 1, where we've got Unit 8 table of contents as our page number 1, as I just stated, and pages 2 through 3 into the Universe Day 1. Here is our Go Blue. Again, feel free to pause the videos as we go, guys. Always make sure, again, I usually will go at a faster pace. For announcements, workbook pages 323 through 326 are going to be due at the end of the week. That is Sunday night by 11 p.m. So make sure you submit those sooner than that to get the full credit. Also, we've got a notebook check and a unit quiz beginning at the end of this week as well. I'll have the notebook check post and the quiz post probably by Thursday night or Friday morning ready for you guys. Well, let's go ahead and check out our Go Blue on page 2. Write these blue questions down. What is the setup of a lunar eclipse? What is the setup of a solar eclipse? And what is the difference between neap and springtide? Take a moment, think about it, draw it out, answer. And your answers are going to include lunar eclipse, guys. Okay, it's when the moon is being blocked off from the sun by the Earth. So as we wrote in actually our recent lab assignment, if you guys recall from memory, hopefully, again, sun, moon, and Earth, or sun, Earth, and moon, with moon in the back being completely covered in shade by the Earth. And then we have a solar eclipse. Now the sun is being blocked by the moon. Okay, so lunar eclipse, moon being blocked, solar eclipse, now the sun is being blocked from the Earth's point of view, right? So again, lunar eclipse, sun, Earth, and moon. Solar eclipse, sun, moon, and Earth, and the moon in the middle. Okay, so lunar eclipse, Earth in the middle. Solar eclipse, moon is in the middle. We experienced a solar eclipse just a few years ago. And then spring and neap tides, guys, simply put, what's the setup? The setup is for our spring tides, we're going to see a linear format here. So sun, moon, and Earth are in a line, which means we're going to get higher high tides and lower low tides. And with neap tides, it is in an L format, in a right angle format, which means we're going to get more moderate tides, right? More lower high tides, higher low tides. So then spring tides are more extreme, higher high tides, lower low tides. Linear format, neap tides are in a right angle format between sun, moon, and Earth. And again, just so you guys know, again, spring tides, higher high tides, lower low tides, with the moon and sun working together. So linear setup with moon and sun working together. And then neap, and again, this would be down here. That would be a neap tide, right? Because they're in an L format, not in a right angle. Lower high tides, higher low tides, perpendicular setup, right? We see this here, an L setup with moon and sun working against each other. Okay, let's move on to some new stuff today. Title page 3, Into the Universe notes. What I did have was we were going to watch a documentary for 2 to 3 days with Stephen Hawking, really amazing stuff called Into the Universe. What I did, because I'm not going to make you guys pay for a movie on YouTube. What I'm going to do is I kind of broke it down in a presentation format so I can make it as easy as possible for us to gain the content within a 15-minute time frame rather than making you guys pay for and watch a movie at home. So let's go ahead and start. Before that, our first practice question, we've got to know our moon phases, right? Which moon phase is being shown in this image? Is it A, first quarter, B, third quarter, C, waning gibbous, or D, a waxing gibbous? Again, keep in mind it's a half moon, and it is shaded on the right side, okay? It's going to be B, a third quarter moon, B, third quarter. Keep in mind, guys, anytime it is light on the right, it's waxing. Shaded on the right is waning. Light on the right, it's first quarter. Shaded on the right, it's third quarter. So that is a B, a third quarter moon. It's going to be getting darker. It's going to be more shaded, and it's going to become a new moon eventually. All right. So with our first topics of the day, I do want to mention red and blue shift. So let's go ahead before we begin on page 2. Below your Go Blue, write these 3 questions down. What is the difference between redshift and blue shift? 2, how do these terms relate to our stars and galaxies? And that should have a question mark on it. My apologies, guys. Little typo there. And then 3, are most stars, and actually, let me just go ahead and fix that now. Why not just fix it? You know what? Hey, we're all human. We all human. We all make mistakes, right? No big deal there. There we go. Fine. It took a little while, but it loaded. All right. So let's go back here. And are most stars in redshift or blue shift? Let's find out what that is all about through our first video of the day. Again, I'm only going to show half of it, but it's your guys' responsibility to watch all of it on your own as well. Okay, so let's go check this out. A little sample. I'll show you again. You guys will be watching all of it on your own. I'm just going to show half of it.
Welcome to our universe. Today we'll be answering the question, what is redshift? So this is going to be quite a quick video, basically explaining what redshift really is. So astronomers often use the term redshift to describe how far away objects really are. To understand what cosmic redshift is, we must think about sound. A great example of this is a police car. You hear its siren because the waves travel through the air into your ear. If the police car is moving, then the sounds in front of it are compressed and create a higher frequency sound. And the sound waves behind it are stretched out, creating a lower frequency sound.
Okay, so key thing here, guys, is redshift versus blue shift. It's all about frequency of waves. Like you just said, when a police car siren or a car siren is going around, you're noticing as the car approaches, that sound's going to increase. It's going to get louder. As the car goes away, it's going to decrease. That's because the frequency of these waves is being more spread out, right? So again, anytime we have waves getting closer, we have blue shift because those waves are getting compressed. If those waves are spreading apart, we call that redshift, right?
As the police car passes in front of you, you would hear the familiar Doppler shift. Light is quite similar. It also travels in waves, and it's quite a similar process to what is happening within the waves. Light waves are able to be compressed and stretched, just like sound. But with sound, you would change the frequency, but with light, you change the color. Blue light has shorter wavelengths than red. When an object in space moves towards us, the light waves are compressed into higher frequencies.
Okay, so again, it's your responsibility to watch the last 2 minutes of that, but this does have to relate to our space as well. So let's get into some of these really quick because I'm running low on time here. Okay, so redshift. Objects are moving, actually, as an object approaches, pitch increases because waves are compressed as you saw. Make sure to write these, what's down in yellow, guys. This is going to be redshift and blueshift for the title. Write these down on page 3. Pitch increases because the waves are compressed. As an object moves away, the pitch decreases because waves are stretched. And we call this, as was stated in the video, the Doppler effect. It's the change in light and sound as an observer moves from a source, right? So what does that all entail? As we saw in the video, redshift, okay, objects are moving away, right? Away from a source, that's causing stretched waves. Blueshift, objects are moving towards, and this was discovered by the Hubble Space Telescope because most space objects are in redshift because the universe is expanding. So that's why most stars appear to be yellow, orange, or reddish in color as opposed to blue, because the universe is expanding, right? So again, redshift moving away, blueshift moving towards, okay? All has to do with the waves, and it's demonstrated through our galaxies, through the view of our stars and our galaxies in space from our telescopes. Why most objects in space, most objects that have to do with light waves, things like that, are moving away. Now, question is, why are objects maybe moving away in space? Well, again, make sure to write those 2 slides down on page 3, guys. Pause the video for our notebook check coming up on Friday, okay? Well, there's this idea we've all probably heard about called the Big Bang Theory, okay? Now, what does this idea entail? This is the idea as to, again, as far as science is concerned and how the universe began, science can only explain the physical realm. So just as a precursor to this, anything regarding the universe starting outside of the physical realm, science can't answer those questions, right? Science can't answer all of life's questions. The human psychology in regards to everything outside of the physical realm, science has no place to answer those questions. So what science tries to do is it just tries to answer things from a physical, from a perceptual perspective, things we can see, right? Things we can actually provide and actually physically observe in experimentation, right? So for that sake, as far as science's explanation of how the universe began, they theorize that it was this mass explosion in infinite dark space, right? And it was at a single point where this infinite energy just caused this expansion. Now, maybe it wasn't exactly like a firework explosion like many would like to think, but more so a spreading out of mass amounts of energy, right? So approximately it's 14 billion years old, and there's this war between matter versus antimatter, and in that war, matter won out and was left over in that war of matter versus antimatter. And that you kind of see that a little bit here in the images with all the particles and such. So this was in our film that we would have watched if we were in class. And this is our last thing of the day, guys, no worries. But let's go, let me show you, I want you guys to watch this on your own as well. But I'm gonna show you a little glimpse as to what this theoretically, this Big Bang may have looked like in space when it did happen, theoretically, right?
To see it, we'd have needed some kind of cosmic night vision.
So this little tiny infinite ball of energy, right?
But even this, a view from the outside, is impossible. Again, it sounds strange, but space didn't exist then either. So there was no outside.
No planets, just infinite energy.
The only place there was inside. This early universe was a very strange thing indeed. There's still much I'd dearly love to know about it, but standard concepts of time or space don't really apply. It was just a very tiny, ultra-hot fog of energy.
Yep. And then suddenly, what happened? The Big Bang.
Then it expanded.
Infinite expansion of energy.
With a tremendous flash of
So not
radiation.
necessarily explosion,
From
expansion
smaller
per se,
than
right?
an atom to about the size of an orange in less than a trillionth of a second. Almost no time at all.
You guys can watch the rest of that on your own.
The
Again,
universe
just this.
simply inflated into.
Not sure what happened there. Okay, so just kind of an infinite expansion, and it kind of flowed out into what we now know as space, right? All right, let's finish for the day. I've been talking about stuff for way too long. Just three things of information today, guys. On page 3, we had our video questions there that you'll need to answer. All right, so let's get to our last question of the day, guys. A blank moon is getting brighter while a blank moon is getting more shaded over time. Is it A, crescent gibbous, B, gibbous crescent, C, waxing waning, or D, waning waxing? The correct answer, pause the video, think about it, is going to be C, waxing, getting brighter, like when you're waxing the surface of a car, right? Makes it brighter and shinier. And waning is going to be getting more shaded. All right, guys, that concludes our stuff for today. Again, don't forget, workbook pages due Sunday at 11 p.m. You've got the also the notebook check, as well as the week 4 unit quiz coming up on Friday. So those will be due that same time Sunday night as well, Sunday at 11 p.m. But make sure you get started on those as soon as possible. Get your notebooks up to date with me on our YouTube video lessons. If you guys have any questions, feel free to message me. All grades are up to date as of now, so I will check on some other late turn-ins for other assignments, but all grades as of this most recent Sunday are completely up to date. So stay on track with everything. If you have any questions, message me. Again, on Edsby Messenger. And this is Mr. Campbell signing out. Take care.